All right, so we have a second day of partial fractions. These are a little bit more algebra, so probably not on the AP test because it'll take too long. But so if we write this out, that's going to be, I don't really want to write that whole thing, but plus 4x plus 4. I guess, yeah. All right. Too late now. Okay, so that's going to be a over, it's going to be this will be x plus 2, x minus 2. So we're going to start with the x minus 2 since that's by itself. And then we'll do an x plus 2. And then we will do an x plus 2 squared. All right. So that is fine. Now if we multiply the whole thing by this, that's going to knock all of that out of there. So that's going to be 5x squared plus 4x plus 4. Here we're going to have a times x minus x plus 2 squared. The x minus 2's cancel. Here we'll have one of each. So I'm just going to write that as x squared minus 4. X plus 2, x minus 2, difference 2 squares. It's just a little bit simpler there. And then down here at the end, we'll just have an x minus 2. Okay, so what should we try first here? How about something that's going to cancel? Can we cancel? What if x equals positive 2? Okay. If x equals positive 2, that's going to cancel out both of those, and I should just be able to find a. So 2 squared is 4 times 5 is 20, plus 8 is 28, plus 4 is 32. So that would be 32, and that's going to be 16. So that's going to be 16a. That will be 0, that will be 0. So a equals 2. All right. What else would be good? What about negative 2? If x equals negative 2, that's going to give us still 20 here, but now it's going to give us minus 8, so that's 12, and then plus 4 is 16. Okay, a negative 2 in here is going to give us 0. A negative 2 in here is going to give us 0, and then we're going to have negative 4c. So if we divide by negative 4, we get that c equals negative 4. Now, there's no way to eliminate both of these, but we already know what a and c are. So we want to pick something that's going to be easy for us to calculate. So I'm going to let x equal 0. So I let x equal 0 over here, that's going to be 4. Now we know that a is 2, so that's going to be 2, and then if I let 0, that's going to be 4. B, we don't know what b is. If we let 0, then it's going to, I should put negative 4b right there. And then down here, if c is negative 4, and if I let 0, that's negative 2. Okay, so that's going to be positive 8, and positive 8 is 16. Then subtract that to the other side, so that's going to be negative 12. And then if I divide by negative 4, I'll get that b equals 3. Okay, so now I can put that all back together. So that's pretty much kind of the same as our last example on day 1. So let's see how this is going to look over here. A was 2, so I'm going to have 2 times the integral 1 over x minus 2 dx, and b was 3, so I'm going to have plus 3 times the integral of 1 over x plus 2 dx, and then down here c was negative 4, and kind of similarly to the one we had at the end of our last notes, I'm going to actually put this to the negative 2 power, and then just use the rule there, because with a u substitution, du equals dx, so I can just do it like it is right there. So that's going to be 2 times the natural log of x minus 2 plus 3 times the natural log of x plus 2. Now I want to be careful here. It's going to be negative 4, but add 1 to the exponent. So that's going to be to the negative 1 divided by the new exponent. So multiply by negative 1. So that's going to be positive because of that. And then plus c. So we could combine these if no, take a square up in there and a cube, and then that's not really any simpler, I don't think. I mean, like I said, this is pretty unlikely to be on the test anyway. But I could rewrite this. We don't usually write stuff with negative exponents, so that would be a change. So I probably could have just done that from. Alright, so you see that takes too long. I'm not going to put that on there, I don't think. Okay, so alright, so this is just telling you, I just read that real fast, it's telling you linear factors, we can usually pick values of x to make it nicer. If you have a quadratic, you're probably going to have to solve a system of equations. Okay, so if we look at this, we want to start with factor by grouping. Your clue is that there's 4 terms. So we're going to factor out an x squared out of there. That's going to leave us with x plus 2. Now remember, when grouping, you should get the same factor over here. Well, that's just going to be 1 then. So now if we factor out the common factor of x plus 2, then we're left with x squared plus 1. Okay, now that we're doing these video notes, if you have questions, make sure you ask questions in class. When you come to class, let me know. We can get the notes out and look at them and see if there's things you need to look at. Okay, so the rule for this is we have x over what? X plus 2, x squared plus 1. And we're going to start off just the same as all these other ones, a over x plus 2. Now, the difference comes in right here. When you have a quadratic factor, like x squared plus 1, what you need to do is you need to go down 1 from that, so it's going to be bx plus c. So that's the difference there. Now, we're going to solve for a, b, and c right now. This is a pre-calculus question. When we put it back in here, that's what makes it calculus. So when we go to integrate this, we're going to separate this. We're going to put bx over x squared plus 1, and we're going to put c over x squared plus 1 and see what happens there. But let's come back to here. So if we multiply this whole thing by the denominator, that's just going to give us an x right here. And we're going to have a times x squared plus 1. And then we're going to have bx plus c times x plus 2. Alright, so we're going to look at this and decide how we want to do this, but I do notice that if I choose negative 2 for x, that will actually cancel this whole thing out. So that'll work out pretty decently. So I'm going to have negative 2 equals, and that's going to be 5a. So a is negative 2/5. So that's kind of the first thing there. Now, let's notice that there's no x squared term over here. Okay? So what that means is that for x squared, if we focus on the x squared, this x squared equals 0 over here. So that's going to be 0. Now, if we move across here, we would have, if we distributed this, I'm just focused on the x squareds here, so I just want ax squared. And here, if I multiply this out, that's going to be bx squared. Okay? So I know that a plus b has to be 0. So a plus b has to be 0. And I already know that a is negative 2/5. So negative 2/5 plus b equals 0, which means b needs to be positive 2/5. Okay, so we got that. We got that. And so now we need to solve for c. Now, if we focus on c, and we multiply this out, we have 2c. C, we can focus on the constants. There's no constant. The constant's 0 also. So the constant is 0. So where are we going to get constants? Well, right here, that's a. If we distribute that, and if we multiply this all out, we get 2c. Okay? So, again, we already know what a is. A is negative 2/5. So we have negative 2/5 plus 2c. So 2c, add 2/5 to the other side, and then multiply by 1/2. So c is 1/5. Okay? So now we can go to work on that. So if we're integrating this, a was negative 2/5, so we can factor out the negative 2/5, and we have 1 over x plus 2. Okay. Now, if we go to this b was 2/5, so we're just focused on this right here. So plus, now I'm going to make a, well, maybe I won't. So if I take the 2/5 out, integral, and down here, it's bx. That was 2/5 x. So actually that's going to be an x up there. And then that's going to be x squared plus 1. And then the last one, c was 1/5. So if I take 1/5 out, that's going to be 1 over x squared plus 1. And that one might be a little bit awkward. So this one we've been doing a lot the last couple lessons here, so that's just 2 natural log of x plus 2. Now here, I should have left myself a little bit of room here, a little bit trickier here. That's going to be u equals x squared plus 1, and so du is going to be 2x dx. And the thing is, we have a 2 right here. So we can bring that 2 back in, and that works out pretty nicely for us, that we're going to get du there and u here. So that's going to be, this is 1/5, and that's going to be 1 over u, or du over u. So that's still going to be the natural log, and then we're going to plug u back in. So that's going to be that. Okay, hopefully you followed that all right. And then, stepping over here, this one probably is going to throw you off a little bit. Threw me off for a second. That is actually the inverse tangent. If you remember, the inverse sine and inverse cosine have square roots down there. Or secant, sorry, secant, inverse secant has the u times the square root of, anyway, this will be the inverse tangent of x, I don't really need parentheses there, plus c. Okay, so there's a couple of different things going on there. Oops. Okay, good times, good times. All right. And 2 more. So again, 3 terms, factor by grouping. This is almost the same question. Not really excited to do this. I guess there's a small difference there. Yeah. All right. So factor by grouping, that's going to be x squared 2x minus 1. Here we can factor out a 4. So That's going to be 2x minus 1. So we've got x squared minus x minus 21 over 2x minus 1 and x squared plus 4. Okay, so we have a linear factor, so that's just going to be a, 2x minus 1. And then we have a quadratic factor, so just did one like that. It's going to be bx plus c. Alright, that's going to be over x squared plus 4. So now we're going to multiply that whole thing by the common denominator. So that's just going to leave us with x squared minus x minus 21. And then a times x squared plus 4. And then bx plus c times 2x minus 1. So this looks like it's going to be a little bit more challenging maybe, but we'll see. So I do see a nice x down here again maybe, except it's a fraction, but so that's going to be 1/2. If we let x equal 1/2, we might get something decent out of this. So 1/2 squared is 1/4. So we're going to have 1/4 minus 1/2 minus 21 equals, and 1/2 squared is 1/4 plus 4. 1/4 plus 4, 1/4 plus 16 over 4, that's 17 over 4. So it'll be 17 over 4a, and then 1/2 here, that's 0. That's why we picked it in the first place. That'll knock all that out. So back to this side over here, that's going to be negative 2/4, so that's negative 1/4. So negative 1/4 minus 21 is negative, what, 85? Negative 85 over 4. So we have negative 85 over 4, and then we're going to multiply both sides by 4 over 17 to get a. So that's going to cancel, and that's nice, that's negative 5. Okay, so that's not that bad. Now, so the rest of this it's almost the same as the last problem we did, so you ought to be able to pause this and knock it out. But again, so now I'm going to look at the squared terms, I guess. So that's going to be 1, so we focus on x squared. The coefficient of x squared is 1. I guess I could just, did I write it down? No. I'm just going to focus on the coefficients. So 1 on this side, and on this side I'd have ax squared, so that's just going to be a. And here I'd have 2bx squared, so that's going to be 2b. Okay? So we already know that a equals negative 5, so if we have negative 5, we add 5 to both sides, that's going to be 6. So b is going to be 3, and probably we're going to look at the constant again, so just like we did last time. And there's other things that we could do if we had to. We could do a whole matrix and do a system of equations. Don't want to have to do that, but we could. So the constant is negative 21, and here we would have 4a, and then down here we would have minus c. So we're trying to find c still. So if we plug that in there, we have negative 21 equals negative 20 minus c. So if we move that over here, that's positive 1, so we get that c equals 1. All right. So let's see. Same kind of thing. A is negative 5, so negative 5. And the integral, we factored it out, that's 1 over 2x minus 1. It's going to be our natural log. Now we're going to split this. So b was 3, so that would be 3, factor the 3 out, leave the x over x squared plus 4. And then this last one down here is c equals 1. So that's going to be 1 over x squared plus 4. And what is thinking about something there. Okay. So this is going to be negative 5 natural log 2x minus 1. Alright, here we don't have the 2 up there. If we're going to do the u substitution like we did in the other problem, we don't have that 2 to bring back in here. So that's going to give us a 1/2. We're going to need a 2 over 2 to bring a 2 over here. So that's going to be 3/2. And then that would be 1 over u, so that would be the natural log, and then we can plug that back in. So if you need help on that, come into office hours and I'll show you. It's just a u substitution. You're letting u equal this. So du equals 2x dx, and there's no 2, so you have a 1/2. So that brings that 1/2 over there. Now this one, a little bit trickier here because it's, if you remember, the formula is like u squared plus a squared or something like that. So here a is 2. Okay, I don't know what happened on this last one. On the last one it was 1. So that's why it was, so the last one here's a 1 here, so this didn't happen. But if you remember, you probably don't because I don't really, but it's 1 over a when you integrate. So the clue is that it's not square rooted. So if it's not square rooted, that's the inverse tangent again. So it's 1 over a. So a is 2, the square root of that. So it's 1/2, and then the inverse tangent, and then it's x over a in here also. So this is 1 over a, and this is x over a. Whew. Okay, and then plus c. So I think you can see that BC kind of takes it up a notch from AB. You got to do the algebra's harder. There's more steps. It combines several things. So, all right. Let's see what we're doing here. Repeated quadratic factors. Again, not going to be on the AP test. It's too much going on here. But let's see what we're going to have here. So, anytime you have a perfect square in the front and the back, you can check to see if it's a perfect square. So you square root that, and you square root that, and think about what would happen if you squared that, and you would get this. So we're going to have 5x cubed plus 3x squared plus 7x minus 3 over this. Now, just like linear factors, we're going to start off with just x squared plus 1. And so that's going to be ax plus b, kind of like we had bx plus c before in the last two. And just like with linear factors, if it's higher powers of that, we have to list those out again. So now we're going to have to square that. And if it was cubed, we'd have to do one more with cubed. And the numerator is going to stay in that same pattern though, so that's going to be cx plus d. Okay? So now if we multiply by the common denominator, that's going to knock this whole thing out on this side. And then here we'll have one of those left, so that's going to be ax plus b times x squared plus 1. And here, that's going to knock out all that, so that's just going to be cx plus d. Okay? So, is there anything that we can do with this? Well, let's focus on x cubed. Okay? So, on this side, there's only one x cubed. That's if we multiply ax times x squared, that's ax cubed. So, we're going to have 5 equals a. That's the only thing that can happen there. Okay. Now, let's think about next. There is only going to be one squared term also. I guess we could multiply this thing out if you want to. So even if you don't want to. Ax cubed plus bx squared. What do we have over here? Plus ax plus b. plus ax plus b plus, okay. So instead of listing out a whole system of equations and plugging numbers in for x, we can just start identifying certain things here. So similarly to noticing that the cubed had to be there, now we can notice that the squared, there's only the one squared term, so b has to be -3. So x squared means b is, I don't know why I flipped those over, but okay. So now we're getting closer there. We can focus on the x's. So x is 7. So focus on x. We have 7, and that means a plus c equals 7. A plus c equals 7. And we already know that a equals 5. So c equals 2. And then finally the constant. So I don't want to write c for constant because I already have a c there, so I'm just going to write -3, and the constant's going to be b plus d, but we already know what b is. B is -3, and if we add 3 to both sides, we get that d equals 0. So that's probably good for us. Okay, so let's try to decide what color to use now. So if we plug the stuff back in, I suppose that would be the easiest way to look at this. So a was 5. So we have the integral of 5x minus 3 over x squared plus 1. All right, and then 2x over, looks like a u substitution in our future. All right, so that looks fine. This one we could split up. So I can factor out a 5 here and have x over x squared plus 1, and then minus, I'll leave the 3 in there and just have 3, wait, just kidding. I still have the denominator. I was about to get rid of the whole denominator. So I'll just leave the 3 there for now. I can factor it out after. I don't have a lot of room right there. X squared plus 1, and okay. And I'm going to do a u substitution down here. So u is going to be x squared plus 1. So du is going to be 2x dx. And we do have a 2x dx right there, so that works pretty nicely. So that's going to be plus, that's going to be u to the -2 du. Okay, so down here, all right, so down here we have a u substitution here technically. Probably I should do that. If I let u be x squared plus 1, then du is going to be 2x dx, and I don't have a 2, so I have to do that 1/2 there. So the 1/2 is going to come out here. We're going to get 5/2, and then the x dx is going to be u, and this is going to be du, and this is going to be 1 over u. So 1 over u du, that's the natural log, and then we would plug u back in. So not too bad there. Now here we could factor out the -3, and this takes us back to example 2, which is that 1 over x squared plus 1, which is just the inverse tangent. Okay, so that's not too bad. And then over here, add 1 to the exponent, so u to the -1, then divide by the new exponent, so that's going to make that negative. And then that's going to be 1 over u, because u to the -1. And we can plug that back in as x squared plus 1. So, bam. So all that was pre-algebra up there, and then boom, add some calculus to that. All right, it's about that time. Have a good day.